Okay, so we're getting the PowerPoint presentation up. This is Intro to D-Star. Some of you may have seen this presentation already. I started doing this about 2.5 years ago. I've done it about 4 dozen times. So as time has moved along, I've refined the presentation, learned met a lot of people. How I got involved in this was actually started back in the 70s, and I started doing digital back in the 70s using a Model 15 teletype. And about 10 years later, in the middle 80s, got involved in packet radio, very actively involved in packet radio, when packet radio was booming. And that kind of culminated about 10 years ago with doing the DCC here in Chicago. And then I was very busy for many years, and back around maybe 2004 or 5 at Dayton, I saw this D-Star radio thing in the Icon booth. And I think I probably walked away with more questions than I had answers the first year. And then I came back the next year, and the booth was a little better. And then I came back the next year, and they had a really, I think it was like, now we're talking about 05, and there was a pretty nice booth. And I decided after Dayton in 05, late in 05, to kind of educate myself. What is this D-Star stuff, and why would we want to use it? Decided early in 06 then that this was kind of interesting. We didn't have any, in Chicago at that time, we didn't have any repeaters up. I think the only repeaters on the air were the guys in Dallas. But I thought, well, let's go out and start talking about this. Historically, in ham radio, digital meant data, didn't mean voice. Now, we all know that's not the case any longer, but historically, that's what ham radio meant. And then, I did probably maybe 2-3 D-Star presentations, and I thought, well, maybe it'd be interesting to figure out what's going on in all of digital, and what people are doing and what they haven't done. And I'm still waiting for this PowerPoint to come up. I said, well, maybe I'll create this Yahoo group. And so I created this Yahoo group, and originally I was going to focus it just on this area, Illinois, but then it kind of became obvious that the issues in digital were really not geographical. They were far more wide-ranging than that. And I started seeding this Yahoo group with dozens of files and links. Never had done a Yahoo group before. And it started to attract attention. And one thing led to another. Now about 2 years and 2 months later, we have like about 2,950 members on this Yahoo group. And combined with the dozens of files and links, the 2,900 members are a real resource. One of the things that you can, and we're still waiting for the PowerPoint here, one of the things you can do on a Yahoo group is you can take a poll. And so what I did, I thought, well, this might be interesting. Not long after I started the Yahoo group, I said, well, maybe I'll take a poll and see what people are doing on digital and what they want to do. And if I had to do the poll again, I think I would probably maybe ask a couple different questions, doing my own naivete at the time, and some things I've learned over the last couple of years. I might ask a couple different questions. But so this is this Yahoo group I was talking about. I called it Illinois Digital Ham initially. Okay, I can see it. There it is. I called it Illinois Digital Ham initially. Sometime in, I was thinking about changing the name, but if you change the name, everybody's reference points are screwed up. So, and what's interesting about this poll is that it really hasn't changed much. It trends almost the same. So the first thing I asked was, well, what are you doing now in digital? And I found out that people are doing APRS, and they're doing PSK31, and they've done RIDI. And then when you ask, well, what do they want to do? And this is where I probably would have asked another couple different questions. I would have asked a question about HF digital voice, which I didn't ask here. But I'm sure if I had asked it, I would have gotten a lot of response. When you look at what people want to do in digital, they're saying D-Star, APCO P25, high-speed multimedia or Wi-Fi, and still PSK31. And what this kind of tells us is that that hams are interested in doing digital voice. They're interested in doing higher speed data, and they're still interested in doing data on HF. What is interesting is that APRS, which is kind of the savior of packet radio, there's not that much interest. And not because it's not valuable, it's just I think people have done that and they want to move on to something new and interesting. So I think the instructive thing as far as the D-Star perspective here is that there is an innate interest in digital voice. And one thing I found over the last couple of years in doing these presentations is that in groups where they hadn't heard about D-Star before, either at Hamfests or at club meetings, we'd fill a room. And we'd fill a room with people. And I think that part of it was D-Star, but the other part of it was digital voice. There's, if you look at the room this morning, it was fairly full here for intro to digital voice. So first thing I'm going to do is I'm going to play a video real quick. It's supposed to last about 4.5 minutes. This video was done in Dayton in 2005 by ICOM, and it's got the guys from Texas who were the pioneers in D-Star. And when this video was done, the only equipment available for D-Star was on 1.2 gigahertz. Now there's repeaters and handhelds and mobile radios for 2 meters and 70 centimeters.
I'm here with Jim, N5MIJ, and Bill, N5ZPR. They're from Texas, and they have set up a D-Star system. If you could tell us a little bit about D-Star first. So what is it?
D-Star is a protocol. D-Star is a new networking implementation. ICOM has the first set of radios out for D-Star.
D-Star is a protocol, but what type of radios do you use?
We use ICOM ID1 mobiles with the RP1 repeater system. We've been testing this for about 1.5 years now. We're learning a lot along the way. We're driving around town now with the functional equivalent of an ISDN line in the vehicle with us. 128K mobile data plus digital voice.
This PowerPoint presentation that you're seeing right now did not exist before we left town to come up here. We literally built this presentation on the road on the way up here with people in 2 different vehicles linked via D-Star for data capabilities. Transfer information, sharing the PowerPoint presentation back and forth, and then using a UHF radio for voice communications to say, no, that doesn't look quite right, do this to it. And we had the graphics team in one vehicle with Bill, and then content team in my vehicle. Bill and I were driving, so we're trying to tell them how to build this presentation. Literally sharing the data between 2 vehicles driving down the freeway.
So it's basically a repeater that has voice and digital for normal voice like a repeater, but also digital for something like the internet.
Correct. The data is actually internet data. You don't have to use it, but you can do internet data from the vehicle.
So how would it work as far as talking to somebody digitally? Do you call up like a normal repeater and ask for a call sign, or how would that work?
Works just like any other repeater does.
Okay.
As far as that application is concerned.
So now this is wireless internet, you say. How fast is it, and how far can you go with it as far as a radius?
We're seeing about 30-mile radius right now. We're on a very tall building in Dallas. We're up about 900 feet above ground level. It's all run at 1.2 gigahertz, so it is line of sight communications.
How well does 1.2 gigahertz work?
Well, the bandwidth required for data is going to prevent having quite the same range that you would have with voice. The voice we have found to be about the same as the analog repeater on 1.2 and very similar to 440 radio.
We don't get quite the range we do on 2 meters or 440, for example, but we don't have anywhere near the congestion or the interference problems either.
So tell me, why would you guys get into this?
It's new.
You can see what we ended up with for a very effective implementation. New technology, new concepts. There are lots of capabilities and opportunities here. We have figured out lots of things we can do with both the high-speed and the low-speed data. Obviously, an internet connection available in the vehicle as you drive around town lets you do lots of things. The low-speed data can happen simultaneously with the voice. There's some interesting possibilities there for what goes on, where you can go broadcast weather warnings, radar, all sorts of things you can distribute that way. This is not IRLP. This is not Echolink. This is very specifically routed information. We're still learning it. If you don't go into it expecting IRLP or something like that, you can be very surprised and have a lot of fun with it.
This capability of throwing data to a mobile is something we've never had before. We're going to find all sorts of applications in emergency communications, interconnection of different command posts, moving data, coordination of special events.
So do you have a backup generator up at the repeater site so that if power goes out, you guys have wireless internet still?
Yes. All run by UPS and generators. We'll run for more than 24 hours in the event of an emergency at this site.
Wow. And what about controlling the unit?
You've got a few things to deal with in setting your radio up where it's configured correctly, but in that, it's no different.
Great.
Just talk.
All right, well, guys, thank you very much again. I appreciate your time.
Thank you, Trevor.
D-Star is a real interesting product, and we hope to hear more from you in the future.
No problem.
Thanks a lot.
So these guys were the first guys in the country to use D-Star, literally. And they're from Texas. In fact, Pete Lovell here, who's going to be doing Intro to DPRS after my presentation, is one of those same pioneers from Dallas. And that was 4 or 5 years ago. A lot's happened since then. There's been a lot of innovation both in Texas and elsewhere. So what is D-Star? Well, they tell me it stands for Digital Smart Technology for Amateur Radio. As you might have heard in prior presentations, especially from Pete, it is an open protocol. It's available to all manufacturers. It's not open source. Nobody's going to teach you how to do it, but they publish the over-the-air protocol. Some of the innovation that ICOM has done is build radios, build repeaters, build a gateway, and hook it all together and build a complete system. And as you've probably heard Robin talk about last night, he was able to reverse engineer. They don't tell you how that all works. That's clearly the innovation that ICOM's done. But as you found out last night from Robin, he's reverse engineered and figured out how it all works. Kind of the typical thing a ham radio operator might do. It's the standard in Japan for digital radio, and I understand that JRL has mandated it as a standard in Japan. So one would expect that over time it's going to be adopted by other manufacturers. One of the questions that always come up in these presentations is, what about the other manufacturers? And I'll just address that right now. Nobody knows, but in Japan, Kenwood sells a rebadged ICOM radio. It's the ID800 that's rebadged. Over the last 2 or 3 years, Kenwood and ICOM and a couple other manufacturers have formed another business band standard, 6.25 kilohertz FDMA protocol called NXDN, and they both, Kenwood and ICOM, make radios for that standard that work with each other with simplex and through repeaters. So, if Kenwood can do that with ICOM, I would think they would be able to build D-Star radios. Well, what is this stuff? Well, it is true digital modulation of GMSK. It's not like we did with Packet Radio, where we took our old SCSI 2-meter FM radio and put a TNC on it. It's not that. It's not APCO P25. That's a different standard, typically used by public safety. A lot of times these presentations, I get questions, well, why don't we just use P25? And you can. There are a number of hams in the Chicago area, because Motorola's headquartered here, who have access to surplus gear, have put up P25 systems, but it's basically just you basically, from a ham perspective with P25, just get a radio that you can simplex or through a repeater. You don't get the whole system. You don't get the concurrent data capability, and you clearly don't get the internet routing and all those kinds of things that are desirable in D-Star. Now, if you take P25 and build it into a big trunking system, which hams aren't going to do, then there's a whole host of other capabilities. But it really has nothing to do with P25. So D-Star was designed for amateur radio, not for business band, not for public safety. I've had sometimes hams come to me in these presentations and say, well, what about interoperability? And I go, well, what interoperability? I mean, we're on ham radio, and the police and fire are on public safety frequencies, and they don't cross over. We don't go talk on the public safety frequencies. The public safety people don't talk on ham radio. So I think that is kind of a non-issue. One of the things about D-Star is that we do get spectral efficiency, and we'll see more about that in a second. And one thing I really like is there's no path noise on weak signals. And I played a recording last night that I'm going to play again that demonstrates that. And on both, on 2 meters, 70 centimeters, and 23 centimeters, you have simultaneous voice and data capability. And on 23 centimeters, you have high-speed capability. Some have likened the transition from FM to digital voice, similar to what we had 45, 50 years ago from AM to sideband. They were disruptive technologies in both cases, and they weren't really backward compatible with each other. So you had to buy, I always say in these presentations, the bad news is you're going to have to buy a new radio, and the good news is you're going to have to buy a new radio. And that's really the reality of it. In both cases, both sideband and in digital voice, they provide better effective range. They use less bandwidth. They were more spectrum efficient. The audio wasn't necessarily better, but it certainly was intelligible. And the technology was initially more expensive, and that was true with sideband. If you look in the old catalogs and look at what those Hallicrafters cost, they were very, very expensive, even in the dollars of the day. So who's deploying it? Well, initially individuals. Usually new technologies start with early adopters, like some of the people we see here at the DCC. The folks in Dallas were the early adopters with D-Star. Sometimes clubs deploy it, and often sometimes you get grant money or served agencies. It's international now. It started in Japan and then came to the U.S., and now it's being rolled out throughout the entire world. How do you use it? Well, you kind of use it in, fortunately here at the DCC we have equipment and repeaters to demonstrate, unlike a club meeting that I might present at. You use it just like regular FM in a lot of ways. I mean, everybody hears everybody. Nothing's encrypted. You can talk on simplex. You can use it through a repeater. It's, to a certain extent, there's a lot of similarities to what you're familiar with. However, there is a call sign encoded in every transmission, and if you put your call sign in, it's your call sign that's encoded. There is call sign squelch in the radios, so that you can just listen for one call sign. Some have asked in these presentations whether there's call sign avoid, to avoid that one person you don't want to hear, but unfortunately I don't believe there is. In terms of spectral efficiency, it's a 6.25 kilohertz wide bandwidth. It's been contended that you could probably put a D-Star signal every 10 kilohertz. And so we're making more efficient use of available bandwidth. And here in like the Chicago area where all our frequencies are allocated, they may not be being used, but they're all allocated. Finding spectrum is always a difficult task, and it's true in any urban area. If we look at it on a spectrum analyzer, we see an FM signal on the top versus a D-Star signal on the bottom. Here in Illinois, Illinois took kind of a leadership role, and Kermit referred to it last night. On VHF, we have a 20 kilohertz band plan on 145 megahertz. And so what we're doing here in Illinois is on 2 meters, we're taking and carving up analog channels that become available in the 2 D-Star channels, plus or minus 5 kilohertz. And on 70 centimeters, plus or minus 6.25 kilohertz. So if we look at 2 meters, and on the top, you can see, the very top there, you can see the bottom green bar, which is the FM channel, and then you're actually able to put 2 within this same band. Well, this is actually UHF we're looking at here. Let's back up a second. There we go. There's VHF. So there we can put 2 5 kilohertz apart from each other for off-center frequency. 5 off, 5 above, and 5 below. And then on UHF, it's 6.25 kilohertz. Now, one of the things you can do on UHF is actually, because we're 6.25 kilohertz apart, with some degree of geographical separation, you could actually have a third channel right on the center frequency. When D-Star came out, if you think about the frequency coordination world, nothing really had changed in 35 years. I mean, FM was FM. And so coordinators had to search for ways to handle this, and I think the Illinois Repeater Association was the leader in that regard, because they did come up with this migration plan that basically took analog channels and split them up into multiple digital channels for repeaters. This is one of the first times where the digital world and the repeater world have all of a sudden merged. Before with digital, repeater coordinators really weren't all that interested in this. They go use these simplex frequencies or half duplex frequencies and don't bother us. But now these are real honest-to-goodness pairs, so you have to find places to put them. And the adjacent states around Illinois, Wisconsin, Indiana, Iowa have adopted the Illinois plan. You do have the capability of simultaneous voice and data on 2 meters, 70 centimeters, and 23 centimeters. As they pointed out last night, it is a 4800 baud data stream, 2400 baud of digital voice, 1200 baud of forward error correction, and 1200 baud of serial data, which is probably effectively 950 bits a second. One of the things that I find, and I mentioned this last night, that I found after doing these presentations is that most hams believe, with no experience in it, they believe that analog is always better than digital voice for a weak signal, with no experience on their own. And it took me a while to try to figure out, well, why do they believe this? And so what I found out was, and I'll play a couple of recordings. This is strong signal D-Star.
Okay, Joey, I'm getting underway, and my GPS should be moving now, so did your computer lock up?
So that's, it got a lot of punch. It's not as full-bodied as FM. Here's weak signal D-Star.
Okay, actually, I am now going underneath an overpass, so I'm going to be as low as I can possibly get. I am underneath.
And invariably, when I do these presentations to just a regular group of hams, somebody in the audience says, it sounds like my cell phone. And I think that's why most hams believe that digital just doesn't work well with weak signal, because their cell phone gets garbled. But what hams can't do with their cell phone is switch to FM at the equivalent power level. So fortunately, we got this recording from John out in Lubbock, and he was out mobile, and this third recording, he's stationary, and he's on FM, or he's on D-Star. It's weak D-Star. We don't know how weak it is, and he switches to FM at the same power level. And this is what I played last night.
Okay, I found a place to turn around. This is KC5ZRQ on digital. Can you hear me? Okay, I'm going to switch to FM. So let's go ahead and switch to FM. This is KC5ZRQ on digital audio. We're going to change over to FM. And this is KC5ZRQ on FM. Test 1, 2, 3, 4, 5. I can hear you. Can you hear me? Roger, Roger. Can you hear me? Okay, what did that sound like when I was on FM? Could you hear me?
Well, when I play this recording to a group of just general hams who have no experience at digital, that's the aha moment. That's when everybody in the room goes, oh, really? I didn't realize this. Just like when Mel Witten earlier here played the comparison sideband and one of the HF digital voice modes, you saw, that weak kind of fuzzy sideband. All of a sudden, there was the digital voice. It was nice and full, and had a lot of punch. In the TAPR PSR journal back in the spring, there was a ham from Texas. I don't remember his call off the top of my head. He did a sort of a little analysis of this, and I took the graphic out of it. And that area up there where the signal starts to drop and then eventually becomes garbled and it falls off the edge, that's that area where you've got a lot of noise on FM, more increasing noise, and where D-Star would still be crystal clear. And I find in my own experience using D-Star that after I go back to FM, after a while, I get kind of annoyed. And I couldn't figure out why for a while, and I realized, it was all the path noise and the static and the varying signal fluctuations, which, as hams, we all have become accustomed to. But I know if anybody has had wives or kids or friends who aren't hams and don't like noise, even you drive around the car with some people, the FM signal gets a little weak, they say change the channel. And I've even gotten to that point now where I've been really accustomed to no path noise. And it's very pleasant. On D-Star Digital Voice, there is low-speed data. It was talked about in some of the other presentations. It's typically being used to transmit GPS coordinates and text messaging. I'm not going to go into all of this in real great detail because this is an introduction presentation. And then on 23 centimeters, there is a high-speed data capability. You could access the internet, you could access the intranet, and so forth. You don't need to use the gate. You don't have to have a gateway, internet gateway on D-Star, but almost all the repeaters do. That's one of the power of it. In terms of that low-speed data, it's transmitted. It can either be transmitted separately from digital voice or concurrently. And so you can actually be talking and transmit a text message, send a GPS coordinate simultaneously while you're talking. You don't need another TNC. You don't need any other radios. There is no error correction. It's asynchronous data. And as we saw, and we're going to see this afternoon, with the DRATS program and other programs like that, there's about 4 programs out there. Originally there was D-Star Chat, and then Dan Smith came up with DRATS. There's a couple other programs. There's one in Germany called D-Term, and there's one in the UK called D-Star-Com, I believe it's called. They're all kind of different approaches to skin the same cat, basically sending text messages with other things. And so it is possible to do text message and small file transfers. And if you go to see Dan Smith's presentation this afternoon, he'll show you more about that. On 23 centimeters, the data is half duplex, 130 kilohertz wide channel, 128 kilobits of IP internet data. So how would you use that high-speed data? Well, one approach might be to, let's say you had an emergency vehicle, you had a switch, you have maybe 2 or 3 PCs hooked to it, hooked up to one of these ID1 radios that can do high-speed data. You could come into the data access point at the repeater site, either go into the internet or go into the internet. And, you know, again, this is where the innovation comes in ham radio. And one of the presentations this afternoon called It's the Network, you're going to hear Eric Westgard from Minneapolis, they've made extensive use of this high-speed data capability to support the Minneapolis Marathon. And, you know, you can run applications on your gateway server that have nothing to do with the internet. They could have a web server, an email server, database application, a FTP server, whatever you might need to support whatever kind of activity your group or public service organization wants to do. So it's not just about browsing the internet. You can do that, but it's not just about that. In terms of internet linking, and this was talked about yesterday too, but when D-Star first came out, and well, it's still the case, the protocol is user-to-user linking, not site-to-site linking. As I mentioned in the video, this isn't Echolink or RLP. You're not linking systems to systems. You're linking users to users. And we're going to see a little example of that in a second. But it does allow for automatic roaming. So, for example, if you're here in Chicago, and let's say you fly to Dallas, and you click the PTT button once on your microphone and access the local repeater there, and you don't tell somebody in Chicago you've left, if they call you, automatically your radio will come alive in Dallas. So it's not as seamless as a cell phone, but it's pretty nice. It's capability that's never been available on ham radio before. If you kind of look at how this works, you've got, at a repeater site, you've got voice repeaters. You may have a data access point on 23 centimeters. They're all hooked to a common controller. That's hooked to a gateway, which is a Linux box running special software designed by ICOM that can either access an intranet, we just talked about, or it can go through a router and get the internet. The gateway controls all the internet traffic, both voice and data. And it is call sign routing. So it's one-to-one linking initially. And it's not site-to-site linking. So there's nothing private on D-Star. Everything's public. You can hear everything on your local repeater. But it can create some interesting situations. This graphic was put together by the guys in Phoenix a couple of years ago, in Dallas a couple of years ago. And it's an interesting graphic. Let's say the user 1 in London is talking to user A in Dallas. And user C is sitting there in the weeds in Dallas just listening. He's going to hear both sides of the conversation. He's going to hear everything that's active on the Dallas repeater. Correspondingly, if user 2 and user B talk to each other, he's going to hear everything. But if user B and user 2 are talking to each other, user 1 is never going to hear them because it's not system-to-system linking. It's user-to-user linking. And that was probably one of the hardest concepts to get hams to understand, because most hams are familiar with RLP Echolink, where you do link one system to another. Everybody hears everybody on each system. Now, there was a recognized need to maybe want to connect system to systems for either public service events or nets or whatever. Built in the new G2 gateway software on ICOM is a multicasting capability. You can broadcast up to 10 repeaters simultaneously. And then we heard from Robin last night, who has written the D+ software, which enables the DV dongle access. It also allows you to link systems together. And you can also do reflector multi-system linking. So that capability is being is there now, and it's kind of the hallmark of ham radio that they'll take so that somebody starts with and build upon it. In terms of the kind of technology available, there are 5 different repeater components. There's the 2-meter repeater, the 70-centimeter repeater, the 23-centimeter. These are all the digital voice repeaters. There's a 23-centimeter high-speed access point, and the controller, which is required. And you can hook any one of those things to the controller, one or more of those. If we kind of look at how it all hooks together, here's a case where you've got the 23-centimeter system. This is what ICOM donated to TAPR, a 23-centimeter system. It's hooked to a gateway. If you look at the full stack of repeaters, which is almost what we have outside in the demo room, the only thing we're missing is the 2-meter repeater. And it's hooked to a gateway server and connected to the internet, or it could be connected to your own intranet. They're not that exciting looking like a lot of computers these days. They're rack mountable. There's no lights of really of any note. There's no audio connections between these modules. They're all digital connections. And one thing to remember, and a lot of clubs I present to already own analog repeaters. There's no mystery with this stuff. It's all FM. I mean, it's all RF. One of the things they found in Dallas when they first put up their 23-centimeter repeaters is that they had some issues. And they're on top of this building in downtown Dallas, a lot of RF up there, tall building. And they found that, they were used to running analog FM repeaters, and they found that they had to do some things. They put a window filter in on the digital or data access point, got some duplexers and antennas, and when they re-engineered and did some good system engineering, they got great coverage. This is on 23 centimeters. And eventually that's what their operation looks like. It's very, very, very professionally done, as you can see. Another system out in California, one of the other pioneers, in the summer of '06 in D-Star, on top Mount Diablo. Again, he's got the full stack there. So let's talk about radios real quick. What's available? Well, one thing about D-Star radios, they're all backward compatible to FM. So if you buy a D-Star radio, you're not giving up anything. You're getting something. You're getting the digital voice capability and the low-speed data capability. And then on 23 centimeters, there's the high-speed capability. If we look at the different radios, the ID1, and I have 2 of these, one in my car and one at home. This is the most expensive radio. One of the things people always talk about, well, gee, how expensive are these radios? And one of the things we find is that D-Star is very similar to FM in the sense that people don't buy radios until there's a repeater up in an area, typically. You're going to get a few early adopters. But just like FM 35 years ago, once you start putting the repeaters up, people start buying radios. And, with D-Star, a lot of it's about digital voice. People want to talk to each other. They want to be social. The first radio that came out was this 23-centimeter radio. It does FM, digital voice, and high-speed data. It's the most expensive, maybe $980, something like that. It's clearly not a radio that every ham is going to buy. But for those who either have a purpose for it, you may be using the high-speed data or just like to use 23 centimeters like myself. We have FM repeaters in Chicago area also on 23 centimeters. It's a wonderful radio. One thing I found using 23 centimeters in a flat urban area like Chicago, and it's probably true in Dallas too, that it works really well. There's a lot of things in life and ham radio also where you've got an assumption about something. Like I said earlier, all these hams assume that digital voice doesn't work well in weak signal. Well, I thought that 23 centimeters would be really, really, really spotty. And when some of us in the area first got our ID1s, we didn't have a D-Star repeater up yet, so we started experimenting with an FM repeater. And it was on a building in downtown Chicago, about 46 floors up. And, if you're on 2 meters, the picket fencing is, kind of so fast, and 220 is faster, 70 centimeters is even faster. On 23 centimeters, I didn't even notice any picket fencing on FM. And perhaps it's so fast that the radio doesn't notice it. But as you drive away from the repeater, the signal would just slowly decay. It was very pleasant, much different than I would have expected, which is, I guess, why you want to experiment on ham radio. So this radio is the most expensive one, probably the least common one. This is a really good value, the ID800. It is 2 meters and 70 centimeters. It's got analog FM. It comes with D-Star. There's no optional D-Star. It comes with D-Star. You know, I don't know the street prices on these. Talk to your dealer, but I think they're probably $500, $550, somewhere in that range. I'm not a dealer, so I don't know. This is the 2820. This is a newer radio. It's dual VFOs, 2 meter, 70 centimeter. You can get an analog version and upgrade it later to the D-Star, or you can buy it right as a D-Star radio. It does have diversity receive in it, which is I don't think any other radio has that right now in ham radio. These are very popular, and you know, probably $900, something like that, with the D-Star capability. Just, you know, if you go to, you know, and these your prices slowly have come down over time, and of course, if you go to a place like Dayton or Hamfest, sometimes they can become even more competitive. The 91D was the first dual band HT. You could get this as an analog version, or you could get it as a digital version. You can still buy it. I've seen prices of these from $350 to $400, depending on where you buy them from. It's certainly not more than $400 new. 92AD. This is the newest HT. This is waterproof. Unlike the 91AD, it's got 4 power levels. It has the ability to have an optional GPS mic. You don't have to put a GPS mic on it, but there is an optional one. There's also a non-GPS mic available. This is a little more expensive, probably in the $500 range. And then the microphone, depending on which mic you get, the GPS mic is, I think, $250 to $300, something like that. For those that really want the GPS capability, it does give you interesting capabilities. But if you want to save money, you know, the 91AD is certainly, there's nothing wrong with that radio at all, and I've got one of those. There are other radios available. Some of the earlier D-Star radios, a 2 meter only mobile. You know, but the thing is with these is that there's limited memory capability with this radio, and you can probably spend $350 with the D-Star option, but you can get it without D-Star. And then there are 2 monoband HTs for 2 meters and 70 centimeters. Again, they have some of the same limitations 2200 has. In this area, the U82 is really not usable because I understand it doesn't do 6 1/4 kilohertz tuning steps. So, you know, here we have to do, because of the way our band plan's designed, we have to do 6 1/4 kilohertz tuning steps. What's going to make D-Star, I think, continue to be viable over the years are the kind of applications and innovation that's being done. You know, if you think about packet radio almost died completely 5-6 years ago. If it hadn't been for APRS and DX packet clusters and things like that, it was the applications that made the mode to continue to be useful. And like I've said before in these presentations, in 1960, you could go to a sideband convention at the Statler Hotel in New York, and 35 years ago, you could subscribe to an FM repeater magazine, and 15, 20 years ago, you could join a packet club. None of those things exist anymore, and the reason they don't exist is because the sideband FM and packet are just modes now. And I think ultimately that's what you're going to see with D-Star. It's just going to be another mode. What you do with that mode will determine how viable it continues to be. And so there's a number of things that people have already done with D-Star. We're seeing some of this at the DCC, and there's going to be a lot more that's going to occur over time. One of the things being the ability to transmit call sign and GPS coordinates. If you think it from maybe a Skywarn capability, or you've got units in the field, to be able to know where somebody is without them by voice saying, well, gee, I think I'm at Route 32 and Route 45, and I'm over by the big elm tree, you know, or by the red barn. I've heard all kinds of horror stories about that kind of thing in Skywarn and spotting. I did this presentation up in Madison, Wisconsin, where they get some pretty vicious storms, and they've got some really hardcore Skywarn people there, like they do in a lot of areas of the country. And they were using business band and TAM radio, and they had a business band repeater, and they were thinking about getting Verizon data cards in their laptops, and when I started to describe what you could do with 1.2 gigahertz, the 23 centimeter capabilities, they're all excited. They said, well, gee, you know, we could download pictures or download radar maps from the Northwest National Weather Service. We could upload pictures of clouds, and they got very excited about that. I'm not going to go through all these in great detail. Some of them were talked about before, but there's a list of some of the applications available. I'm not going to get in and talk much about DPRS because Pete's going to come up next and talk about that. but it is the ability to collect GPS information from D-Star radios, display it graphically on a map, and integrate it in with the APRS world. And there's a number of, as I said, text messaging applications that have become available. One of the original ones was D-Star Chat, which was pretty popular for a while, but now that DRATS is out, and we're going to hear from Dan Smith again this afternoon, it offers all kinds of extra things in terms of file transfers and maps and things of that nature. So that's what DRATS looks like. The DD dongle is something that came out last year that's been very popular. It's the ability to access the D-Star network through the internet from your PC. All you have to do is be registered to a gateway, and you can access any other D-Star repeater where the gateway is running the D+ software. It's about $200. It works really well. It's easy to use. And for those people who travel or maybe be in areas where there isn't a D-Star repeater, it can be really handy. There is a program called D-Star Monitor, and if you go on dstarusers.org, and you don't need a D-Star radio to do this, you probably saw it yesterday, you can see everybody who's used D-Star. Kermit last night talked a little bit about what's been going on in our area here. I'll just very briefly, 145.67 is kind of around the country kind of been standardized as the simplex frequency. Of course, that varies on your band plan, what it's being used for. In Minnesota, they use it as a packet frequency, so you probably won't be using it there. But around here, we've been using, before we put up the repeaters, we used 145.67. I've heard some talk around the country using 441.0 for simplex. There's nothing's official. The first repeater we grew up in the Chicago area was the Fox River Radio League at 370 feet out in the western Kane County, about 45 miles west of downtown Chicago, with all the antennas, multi-bay antennas facing eastward, covering all of the western suburbs. And then last summer, we put up a repeater in Chicago in a 56-story building with 70 centimeters and 23 centimeters, enhanced the antennas this summer. And those two provide pretty good coverage of a large portion of the metro area. They're line of sight with each other. And as Kermit mentioned last night, this is a case where we took one frequency, 442.100, split it into two, and 6 1/4 kilohertz apart from each other. There's one user who lives about maybe a half a mile from the Chicago repeater site in a condo building, and he can actually access the repeater because he lives up 20 or 30 floors. He can access the repeater out in the western suburbs and has no interference problems at all on his radio while both repeaters are up simultaneously. So we proved, in fact, that you can put D-Star repeaters 12.5 kilohertz apart from each other, and an end-user radio can be close to one and be accessing another repeater and not be bothered, 5 and 12.5 kilohertz apart. So it's a good testament to the radios and to the technology. This is what the repeater looks like in central Kane County. This is the Chicago repeater. There's more coming. There is a repeater up in Champaign. The gateway's under construction. Champaign is central Illinois. There is another repeater system coming up. The Chicago FM Club, which is a very large repeater club in this area, has 2 meter and 70 centimeter D-Star repeaters. Are waiting for frequencies. They may wait a long time for a 2 meter frequency around here, but the 70 centimeter frequency will probably come in a not too distant future. They have FM repeaters on top of the AM building, which is at 1,100 feet, so that's where they're going to put the D-Star repeaters. So they're going to have great coverage. They already are testing, and we've got one of the club members' houses right now. Peoria, I was down there last weekend and did a presentation. About a year ago, one of the club members donated a full stack of D-Star repeaters to the club. They took them several months to find a decent site. They found a 400-foot tower, and it's pretty flat in central Illinois, so they should get great coverage. That's their frequencies. It was easy for them to get frequencies, but it took them a while to get a site. We've got another full stack of repeaters going up in DuPage County, which is the western suburb of Chicago. There was another benefactor who bought a full stack of repeaters. He too is waiting for frequencies. He has this 23 centimeter frequency, but not 2 meters and 70 centimeters, and that's one of the dilemmas in a lot of urban areas where all the frequencies are allocated. And there's going to be more to come. Kermit alluded to, I think, one in Arthur, Illinois. I think there's a couple other ones in the Chicago area here. In terms of resources, there's the ICOM forum site. There's I didn't know if I put it on here. There's a K5TIT site. They were the pioneers in DSTAR. DSTARusers.org, the Illinois Digital Ham Yahoo group, and there's another Yahoo group called DSTAR_digital run by some hams down in Texas. So in summary, ham radio continues to evolve, and that's just the nature of ham radio, from SSB to FM to packet. And digital voice is just another part of that evolution. I think it's occurred on VHF and UHF a little before HF because it was easier to do, but I think the next great wave of innovation will also be on HF. So, any questions?
I have one about the technology. When you have the call sign of the repeater you're using, okay, and then you have those A's and B's and G's, and I think there's an R as well.
Right.
What does all that mean?
Well, there's a whole separate presentation we could give you about how to program your radio, which we're not doing today, but it might actually be an interesting presentation for next year. But basically, and Pete can fill in with this, but you've got a my call, your call, a repeater 1 call, and a repeater 2 call. And my call is your own call. Your call is the destination call sign, usually CQ, 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 unless you want to direct it to a specific call sign. Repeater 1 is the repeater that you're accessing, and then repeater 2 is typically the gateway. You can crossband over to other repeater modules within the stack if you don't want to use the gateway, but typically it's the gateway. And so you have what the G is in that last column is the gateway. If you're looking at the RPT1 field, the convention in the United States is that the A after the call sign in the 8th position is a 23 centimeter repeater, B is the 70 centimeter repeater, and C is the 2 meter repeater. That's what we've adopted in the United States. They don't do it that way in Japan. And like I say, there is another presentation that I actually took another ICOM presentation, adapted it, and we've done it at local club meetings here. We could spend another 20 or 25 minutes just talking about call sign programming. There is
probably a great need for that.
Well, there is at Dayton this year. There is a fellow, and I don't remember his call sign, who did do some of that during the D-Star forum during the daytime at Dayton, and if you end up buying the Dayton D-Star video that Gary Pierce, who's recording. Part of that Dayton video, you'll get both the daytime D-Star sessions, and then you'll get the evening get-together. And then during those daytime sessions, there was one of those presentations did talk about call sign programming. But I have a presentation also that I could share with you if you want. I could email it to you that has that also generically too. Yeah, just send me an email and I can send you a copy of it. It's not hard, but it's one of those things that you have to think about for a minute. But as new users come online, it is probably the most complicated thing. And that actually leads to one other thing I was going to mention. If you buy any of these D-Star radios, get the software and the data cable for a couple of reasons. First, the software is a whole lot easier to use than trying to program it in front of the radio. The second reason is if you have the data cable, then you can do other things like use the text messaging. Any other questions? Well, next is going to be Pete Lovell. He's going to talk about DPRS. He's the creator of DPRS, so I'm going to be sitting, watch, and learn myself. So thanks, guys.